Today's class we are going to see about analysis of varying section. Okay. So if you have a bar with varying sections, if the bar is subjected to axial load, consider the bar is subjected to axial load P. Consider the bar is subjected to axial load of P. So in this case, here this external load, that is the axial load P, will be same for each section. Will be same for each section. That is section 1, or 2, and 3. Okay. So here you can take the area of this section as A1, this is as A2, and this one as A3. Okay. And the corresponding length you can take as L1, L2, and L3. Okay. So here, since the section is subject to same axial load, the stress, strain, and the length here are different. Okay. Even though they are subjected to same axial load, the stress develop, strain develop, and the length is varying among the three sections. Okay. So the total change in length will be obtained by adding the corresponding changes that is occurred in each section. Okay, so here this change in length will be varied among the three sections. So if you want to find the total strain or the total length that is changed, okay, total change in length, you must add up for each section and you can get the total change in length. Okay. So now consider the first section. So for section 1, okay, sigma 1 denotes stress on the section 1. It is equal to load by area of section. Load by area of section. Okay. So here the load is common, that is equal to all the section, that is P, and the area of the section is A1. Similarly, you have for section 2, stress is given as P by A2, and similarly for section 3, P by A3. Okay. And now you know that Young's modulus is given as the ratio between, that is Young's modulus E is equal to stress by strain. Okay. So from this expression, we are going to write in terms of strain, that is strain is equal to stress by Young's modulus. Okay. Let us assume the Young's modulus for each sections are same. Okay. Now you can write the strain equation in terms of stress and modulus E. Okay. So for section 1, we have E1, that is strain at section 1 will be equal to sigma 1 by E. Similarly, for E2, sigma 2 by E. Similarly, for E3, you have sigma 3 by E. Okay. Now, you know that strain is given by changing length divided by original length. Okay. So I am replacing instead of your strain E as the ratio between change in length by original length. Okay. So therefore, so E1 I can write in terms of del L1 divided by L1. Similarly, for section 2, strain is given as del L2 by L2. Similarly, for section 3, E3 is given as del L3 divided by L3. Okay. Now compare these strain equations, which is in terms of sigma 1 by E and another one del L by L1. So if I compare these two, I will get del L1 by L1 is equal to sigma 1 by E. So that implies del L1 is equal to sigma 1 L1 divided by E. So stress we can get as the ratio between load by area of that particular section. So therefore, del L1 is given as PL1, okay, PL1 by A1 E. Okay, PL1 by A1 E. So similarly, I can write in terms of del L2, that is for section 2, what is the change in length will be PL2 by A2E, and similarly for del L3, PL3 divided by A3E. Okay. So now if I add all those change in length for the corresponding sections, I will get the total change in length of the varying bars. Okay, varying section of the bar. So total change in length is given as del L1 plus del L2 plus del L3. So del L1 I have got as P L1 divided by A1E plus P L2 divided by A2E plus P plus PL3 divided by A3E. So now I can take commonly P by E, that is load by N smallest outside, and remaining will be N1 by A1 plus L2 by A2 plus L3 by A3. So del L. Okay. So this is your expression for change in length, total change in length of a bar. Okay. Del N is given as P by E into L1 by A1 plus L2 by A2 plus L3 by A3. If your N smallness are not same or not equal between the sections, okay, then that is if they have different value of E for each sections, then the expression is rearranged as L1 by A1 E1 plus L2 by A2 E2 plus L3 by A3 E3. Okay. So this is the expression for total change in length of a bar. Okay. So if you have equal value of E for these sections, then this equation 1 will be utilized to find out the total change in length. If you have different value of E for the sections, that is for each section, if you have different values of E, then you opt for, you have different value of your E for each sections, then you can prefer the equation 2 in order to find out the total change in length of the bond. Thank you.